All right, so what's up, guys? How you been? How was spring break?
Aiden looks dead.
Right?
I am
He's been up for 2 hours.
Really?
telling you, constant like 6 hours of sleep thing, not cool. Don't do it.
How many hours of sleep?
6.
6. Man, you have to get up in the morning now. You should be able to have. Wait, so you got up at 9:30 minus 6. Carry the 1. Why are you going to bed so late? Because you got to play the video games.
Cause I got nothing better to do. I don't do enough during the day to be tired.
Wow. Sorry to
Feel
hear
like a
that.
potato in my house.
Lucas.
Hi.
Just for the record, Lucas, Anna, and Foster are not social distancing, and they're in bed together.
This is disgusting.
Yeah, right. So just want to make sure we're all clear. This is all going to be recorded now live too. So.
Well, I guess they'll die. Survival of the fittest.
So I don't have a whole lot for you today, actually. Today's lesson is really, really short, probably the shortest lesson of the year. But I do want to give you all a chance to ask some questions about the last assignment, which seemed to maybe not have gone quite as well based on some of the work I've seen. And then also I just want to remind you that Wednesday is the day the third quarter officially ends, grade-wise. So legally your grades cannot go down at all from what they were before we left on break. So that doesn't really happen to affect much, but it does affect your college grade potentially. So if you have work to turn in, I'd like to have it by Wednesday to go on third quarter. If it comes in a little bit later, it'll probably just be part of your overall grade, but just get whatever work you have. Some of you have not turned in some of the homework. I want to make sure to get all that. So
I put off doing it and then I forgot how to do it.
what?
It.
Don't say all of it. Don't say all of it.
No, I didn't do 5.5A and then
5.5A?
yeah.
Yikes.
I got all the homework assignments minus the CUDA.
So we can look at CUDA if you want. Should we do that?
The back half of the CUDA.
The back half of CUDA.
The CUDA second page is kind of whack.
Yeah, we'll do that one. Do you all have them handy?
Yes.
The back half of CUDA? You don't have it? Anna, what the heck? Foster, do you have it?
No.
Was it one we had to print out?
I went over on the online page because that one you didn't give it to us printed.
No, it's on the website, yeah.
Yeah, but I don't have a printer, so I had to do it through the write
okay.
it.
You can do that. All right, let me see. Give me just 1 second. I will pull it up. No, I won't pull it up. Hang on. I'll pull it up here.
You probably didn't pick this up.
So that was from that week. CUDA double half. This one good?
Yes, sir.
And these are the ones that you're having trouble with? Yeah. Yes. Okay. Lucas, is this a decent place to spend some time? Okay. Should I just start at 15? Is that a good enough place to start? Okay. I don't. If there's something special you want me to look at, I'll look at all of them, but I'll look at special ones. But let's try that. So I'm going to switch to the whiteboard now. So let me just copy. I'll copy the problem over here. So I know you can't all see it. The problem said this: sine theta equals -7 over 25. 270 is less than theta, less than 360. And said find cosine theta over 2. So what I want you to recognize is that this is a Pythagorean triple type problem. 7, 24, 25 makes a Pythagorean triple. So let me just sort of lay out what the original thinking would be here. And that is that we are in quadrant 4, yeah? And sine is negative 7 over 25. So that's going to put me, I believe, right about, now this is not a unit circle, it's just going to put me right about there. So what does there look like? It looks like minus 7 and 25, which makes that leg 24. Take a good look at that. I hope you agree the sine is negative. The angle, remember all of undo statistic, but the angle is actually this, but we treat it like it's this. So if this is our angle here, opposite over hypotenuse is minus 7 over 25. So we want to find the cosine of theta over 2. Now, the question is, where will theta over 2 be? This is not just me answering. I want you to tell me, where's theta over 2 going to be? Again, if this is where theta is, where's theta over 2?
The other side,
Be more specific.
the opposite quadrant.
Yeah, we can actually, yes, we can go a little bit further into that because I can take theta over 2 and tell you that theta over 2 is between 135 and 180. Do you see where that comes from? That's
No.
half, that's half.
Because they divide.
Yeah, divide by 2. So really what this comes down to is that theta over 2 is somewhere in there, where this is 135. And you know that I'm not thrilled about using degrees here, but whatever, there's degrees in the problem, so we'll make it work. So I want you to all understand that. If theta is somewhere in quadrant 4, then theta over 2, yes, is in quadrant 2, but it's in the upper half. By upper, I mean larger angle. It's actually the lower part of it. But this 135 to 180 degree area of quadrant 2. That means that cosine of theta over 2 will be negative. Why is that useful to know? No, not all at once, just one at a time would be fine. It's too confusing. All right, fine, I'll tell you. It's useful to know what the sine of theta over 2 is because with the cosine, excuse me, what the SIGN sine of cosine theta over 2 is because there's a plus or minus in the problem. It's a plus or minus the radical. You see it on my screen? You see it on my screen, yes? So with the plus or minus, I know that I have to do with the minus. So when I go back here, it's going to be minus the square root of 1 plus cosine. And now, to be clear, it's cosine theta all over 2. Right? This is our half angle identity. And this, I assume you're going to have on, at your workstation, wherever you're working on this. So I know that cosine of theta is 24 over 25. So this is minus 1 plus 24 over 25 all over 2. Equals minus the square root of, all right, 1 is 25 over 25. Yeah? So this is 49 over 25 over 2. That's the square root of 49 over 50 minus, which is minus 7 over 5 root 2. Now, I'm going to show you what the answer says for this, because it didn't say that. Here's what the answer says. What's different? Can you see it? The answer says minus 7 root 2.
What's the radical on the top because you can't have bottom radicals.
Right.
Yeah, they're
'Cause that's bad.
So, yeah, so all we've done here is we've just rationalized by 2 square root 2 square root 2. At least to that. So I don't suggest that this has solved all of your problems, but does that kind of make sense? Is it something you can follow? We'll do another one. We'll do another one. Okay, I'm going to pull up on the screen. You tell me which one you want to do, because I mean they're all good. Which one do you want to do here? There's some double angles. There's some half angles.
18.
18. Okay, so we're given cosine. We want to find sine of theta over 2. Now, I want you to look at this real carefully. Theta is between 0 and 90. So we're automatically in quadrant 1. Then if we cut that in half, we're still in quadrant 1, right? So it's going to be the positive square root. So let me go back to the whiteboard here. I'm going to ask some of you to maybe help me out here just a little bit. The problem said cosine theta equaled 2 root 5 over 5 and said find sine theta over 2. The first thing I recommend we do here is turn this into what we consider the wrong notation, but write it as 2 over the square root of 5. Okay, so I'm going to draw a triangle here. Now I'm going to put it on a circle here. I want you to tell me what are the measurements of the sides of this triangle.
2 on the opposite leg and root 5.
Can I put it on the adjacent leg?
Yeah, because
Yeah.
it's cosine.
Yeah. What else?
Root 5 on the.
Hypotenuse.
Dude, all right. Foster, you have the last one for us, or?
5 over 2.
What's the third side?
1.
1.
See, we have to know the third side because we're finding sine. So we're going to have to know sine theta. So sine of theta over 2. Look at your identities. What do you have? What do we have for sine theta over 2?
Just the same one as last time, just with the minus cosine. instead of a
Right.
plus.
So it's the square root of 1 minus cosine theta all over 2. And we're going to keep the plus. I mean, I don't need to write it, but we're going to keep the plus in there because we're in quadrant 1 still. Yeah, exactly right. And cosine theta, you know what's funny? I said we needed this right here, but we don't actually need it, do we? We don't actually have to figure out what sine is. We need to know what cosine theta is. So it's the square root of 1 minus, I'm going to go 2 root 5 over 5, and I hope you see, no matter what I pick of that one or this one, I'm still going to have a fraction. I have to do some cleaning up of fractions here. So let's figure out what this comes out to be. I can write this as 5 over 5. This is 5 minus 2 root 5 over 5, all divided by 2, which is multiplied by a half. So it's 5 minus 2 root 5 over 10. Big old square root. Yikes. Here's the answer. I'm not sure I agree with the 15 to 20 though. Oh, you know what? I get it. Do you see how my radical includes the square root of 10 in the bottom here? This answer doesn't have the square root of 10 in there. It just has 10. So what this answer has done is it has taken and multiplied by square root of 10 over square root of 10. So now 5 times 10 makes 50 and 2 times 10 makes 20. I'm perfectly happy with this answer right here. It's just written in slightly different notation there on 18. So guys, I don't want to make a bigger deal about this than it is. All you have to do, whether it's, let me go back here real quick. Whether we're doing 2 theta or theta over 2, sine, tangent, it doesn't matter. You pull out your identities and you figure out what the expression is going to be, and you think, okay, what do I need to know to find this particular expression? We'll do 17 next. Maybe that'll be the last thing that we do. We'll do that one next. What do I need to know to use that identity? And then if there's an issue about what quadrant we're in, okay, then we'll make some adjustments. But we're just applying these identities. Let's look real quickly at 17. And just want to make sure you can see 17 is this one right here. Cosine is 4/5. We're in quadrant 4, and we're finding sine 2 theta. I think this is probably a little bit trickier than it first looks. I'm going to draw the circle first, actually, here. And after that, I'll open this up for any more questions you have. But let me pull that problem up so I can still see it again. We're told that we are 270 is less than theta, less than 360. We want to find the sine of 2 theta. So remember how when we had theta over 2, we took these numbers and cut them in half? Now, when I'm going to multiply by 2, I'm going to have 540 is less than 2 theta, which is less than 720. You see that? If I'm going to go 2 theta, then I've got a double, double, double. And I end up with this interval. And the question now is, where on the circle does that interval appear? Anybody have a thought?
Quadrant 4, still?
Maybe.
So no.
No, that's part of it. But where is 540? Let's do this. 180, 360. 540 is right there, isn't it? So I think that this region here is all of this right here. Means it could be anywhere in there. But that doesn't matter because we're asking for sine, which means it'll be negative. Okay? Now, what is sine 2 theta? Sine 2 theta is 2 sine theta cosine theta. So I have to give you the part that I haven't copied down yet is that cosine theta equals, whoops, hang on. Cosine theta equals 4/5. Great, but notice that if we're in this quadrant to start with, we're in quadrant 4 to start with, then cosine we know is positive, but sine is negative. So 2 times negative times positive is going to give us a negative answer. It all comes together. So what is sine theta if cosine theta is 4/5?
Negative 3/5.
Perfect. Yep. Perfect. So we have 2 times negative 3/5 times 4/5. 2 times 3 is 6, times 4 is 24, minus 24 over 25. And indeed, number 17 is minus 24. So I don't mean to be silly or overly nerdy here, but these are actually kind of cool problems, I think. Now, I get that some of these problems we do are not always the most fun. They get a little tedious. I think these are pretty cool because you start with this formula and you're like, I don't know how it's going to turn out. And then you start putting the pieces together like, well, I got to be there. Sine's got to be negative. How's it? Oh, if sine's negative, cosine, it all works out. I don't think that there's an obvious way to check your answers here. I'll grant you that. So I don't think that I'm sitting here saying, yeah, once you get done, plug in this and you'll be able to get your answer. I don't know that you can check your answers easily. I think it comes with a little bit of experience and trust that what you're doing works. And obviously, it has to work a few times for you to trust that it's going to work. But once you do a few of these, you'll be like, oh, wow, it does actually work out okay. Okay, I'm going to pause and go back to this and ask if anybody has any more questions that you want to do off this page. I'm happy to do more, or we can go on to the lesson, which will be really short time. Am I hearing that you were ready to go on and learn new things? Okay, that's what I heard. So I want to leave this up. By the way, your sign today is pretty short too, so that's kind of cool. I want to leave this up, and I want you to focus specifically on one piece of what we've done before, and that is this one right here. Take a good look at that. If you have your identities handy, they come off the double angle identities. Because today, now remember, this is one section of your book that I've broken up into 5 days. Really 4 days of learning new stuff and 1 day of review. We're going to look at the squared identities today, which is just sine squared, cosine squared, and tangent squared. And the really, really good news about this is that these might be the easiest ones to derive of all of them. And working with them, okay, could be a little bit tricky, but let's just go through this real quickly, shall we? Let's start with cosine. I'll go 2x here just because it's a little easier. Is 1 minus 2 sine squared x. So this is under the squared identities. So all you got to do, guys, is solve for sine squared x here. Just solve. Which means, let's be really clear about this. This right here, I'm actually going to move over here and make it 2 sine squared x cosine 2x equals 1. Then I'm going to take this and move it over there. So 2 sine squared x equals 1 minus cosine 2x. Divide 2. That's it. Sine squared x equals 1 minus cosine 2x. And the cool thing about this is you don't really have to memorize this formula if you know cosine 2x. And remember, cosine 2x simply came from cosine of x plus x, which is a sum identity. So a sum identity leads to a double angle identity for cosine, which leads to a squared identity for sine. And if this was a normal world, I would probably be ramming this down your throat, making sure you know these. We'd be doing these problems and problems and problems. It's not a normal world anymore. So I'm going to let you just use these as you see fit. But I want you to know they come from something. They're not just made up. They actually do come from something. Okay, well, given that, let's just continue then, because cosine is not really much different than that. Cosine 2x is 2 cosine squared x minus 1. So now we just solve for cosine squared. Add 1 to both sides. So add 1, add 1. So 2 cosine squared x equals 1 plus cosine 2x. Divide 2, cosine squared x is 1 plus. Now what I find really interesting about this is that the half angle identities look very similar. Let me pull up the half angles here real quick. And this is where maybe you start to see how someone could actually memorize all these. The half angle identities, let me just pull this up here. The half angle identities for sine and cosine are very similar. I hope you'll agree. They have exactly the same form, except for cosine has a plus in it and sine has a minus in it. Well, when you go down and look at the squared identities for sine and cosine, you will see that they are basically the same, but cosine has a plus and sine has a minus in it again. So that's what we do. I bet you can't guess where tangent comes from. Look at it real quickly. Anybody guess where tangent comes from?
The sky.
Yes, exactly. How did you guess that? That's really good. Tangent squared x is sine over cosine. Sine squared over cosine squared. So we have 1 minus cosine 2x over 2 divided by 1 plus cosine 2x over 2. Not surprisingly, the 2's cancel, and we get 1 minus cosine 2x plus. And that's tangent squared. In most cases, I think we found now that tangent is just sine over cosine. I don't mean that to be patronizing, but that's generally how we derive the tangent identities, is by finding out what sine and cosine are and then applying it to tangent. So I wanted to shoot, where is my, there we go. I wanted to give you a couple of practice problems here just to see how the squared terms work, and then that's it for today. Okay, so let's try this one. Sine squared pi over 12. So let's just be clear. We don't know what sine pi over 12 is. I don't know what sine pi over 12 is. And I for sure don't know what sine squared pi over 12 is. What I don't want to do is rely on my calculator. Because the calculator is giving me some decimal answer, which is neat and exciting and all, but doesn't really show I know anything. So what do? I'll write this using the sine squared identity, which is 1 minus cosine of double that, which is 1 minus cosine. Oh, hey, I know that, dude. Cosine pi over 6. 1 minus root 3 over 2, all over 2. Yeah? So this will be 2 over 2 minus root 3 over 2 all over 2. 2 minus root 3 over 2, but then dividing by that is multiplied by a half. So it's 2 root 3 over 4. Why, no, sorry, 2 minus root 3. Ha 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 ha. You all knew that though, right? 2 minus root 3. Yeah? Let's figure that out. That's kind of cool. So here's a case where, look, I don't know. I don't know what sine squared pi over 2 is, pi over 12, but I'm going to do sine pi over 12, and I get, oh wait, I'm in the wrong mode. Sine pi over 12, I get 0.2588. Have your calculators handy? Now again, we're not going to use calculators to start with. I'll use it to check myself. 0.2588, square that, and I get 0.066987. Okay. 2 minus the square root of 3 divided by 4 . 0.066987. Hey, work. Yay for us. So I don't think that these squared, we'll do one more here real quick, but I don't think these squared identities need to be super intimidating. Who has questions about this so far? This one. Do you need me to leave it up on the screen, or do you want me to go on to the next problem?
Next problem.
Next problem? Next problem, okay. And this is the last problem. We're going to be done. This is not, again, this is not, we're not breaking a lot of ground here today. Tomorrow will be a different story. Tangent squared pi over 8. I'm going to let you ponder that for a second, and I want you to ponder the fact that A, I don't know what tangent pi over 8 is. B, for sure I don't know what that number is squared. But what I do know cosine pi over 4. Now you notice that I've picked some fairly small numbers to start with. It doesn't matter. You're going to have plenty of opportunities today to deal with other numbers as well. And I'll pull up the homework here, the assignment in just a second. But let's just go through this. Cosine pi over 4 is root 2 over 2, yeah? And 1 plus root 2 over 2. So how are we going to simplify that? I get 2 minus root 2 all over 2 divided by 2 plus root 2 all over 2. I hope you can see that these 2's are going to cancel. We end up with 2 minus root 2 over 2 plus. That's going to be my answer right there. I'll let you check those out on your own to try to figure those out. But the whole point of this is to allow us now to convert some angles that we wouldn't otherwise know the tangent of, and therefore wouldn't know the tangent squared, into angles whose cosines we know, and that then allows us to find tangent squared. Who has questions about this process?
Are there going to be questions when you double like the original angle that it doesn't simplify into an angle that we know?
I can't imagine there would be. I'm just going to look here. Let's do this. It's a good question, Foster. Let me go. I don't have the assignment right in front of me here, so let me go up here real quick. Nope, just kidding. So we're looking at, we're page 388, 1314. I don't know why we're doing that. It's not even a squared problem there. Oh well, whatever. 1920, we're just simplifying 27 to 34. Simplifying again. Probably not going to be your favorite problem we've ever done, but 27 through 34 are just going to have you reduce down to the simplest form. And then 66, yeah, nothing. So you're not really dealing with anything here with weird angles here, just playing around with mostly like proving, identifying, simplifying, that kind of thing. There's not, I mean, there's not many problems in there because these are very specific to just the squared terms. So, you know, here's one thing I know you probably don't want to do. Well, don't even worry about it. Just do those problems, get comfortable with reducing powers down. So cosine to the fourth is cosine to the second times cosine to the second. We know what those come out to be, and you can express those problems as best you can. If those are hard, we'll talk through those tomorrow. Otherwise, tomorrow we're going to do something called product to sum and sum to products, and that's going to be a little bit more involved and complicated. But that's all I got for now. Anybody have anything else to add to the mix? All right, go back to work. I'll see you tomorrow at 11:30, probably for a little while tomorrow. These problems are going to be a little bit challenging. So one thing you might do, just a thought here. Yeah, there are problems in the homework. You might even just try some random angle. Try something over 8 or something over 12, and then find cosine squared or tangent squared or something, and then check it on the calculator just to make sure you understand how this works. That's the whole point today, is to be comfortable with these squared identities and make sure that you could use them if you encounter them. That's all. Okay. I shall see you tomorrow, same time, same place.
All right.
Bye.
Bye.